The second type of solution that you're going to need to know how to mix is those created from a more concentrated solution. So the big problem here is, how are you going to know how much of this really strong liquid to measure out so that you can put it into more water and get the concentration at the end and the volume at the end that you were looking for? Let's hop right into a problem. Making a solution from another solution, like a stronger solution, is called a dilution. When you make something more dilute, you spread out that concentration. You add water and you spread out the particles of the solid or liquid or whatever it is that's dissolved. You spread them out in space. So let's take a look at this example here. How do you make 1 liter of a 2 molar sodium iodide solution from a 3 liter 3 molar stock solution? Well, you want to make sure that you kind of keep track of your information here, because this can get pretty confusing pretty quick. So first of all, you want to keep track of the solution that you're making versus the solution that you're using. And what you're really after is you need to know what volume, how much of this big stock solution, the concentrated solution, that you have to measure out to make the perfect solution, where all you have to do is just add water to whatever it is that you're measuring out. Just like always, any problem that's dealing with molarity, I like to make sure that I have the molarity equation written out. And I want to kind of inspect what I know about this solution that I'm making. Well, one thing that I do know is that I have a 2 molar solution that I'm after, so I can plug that into my molarity equation. The second thing that I absolutely know about this solution is that I want to make 1 liter of it, and I can plug that into the molarity equation. And like problems we've had before, it seems as though we have a pretty clear-cut path forward, that I should probably be calculating the moles of that solute. Now what's interesting is that these moles of material, the moles of the dissolved stuff, come from somewhere. They come from this concentrate. So all of the moles that go into the dilute solution come from the concentrated solution. So they're going to have these two numbers in common. The number of moles is going to be identical on either side. So again, for the solution now I'm making, I can fill in the molarity equation. Another thing that I know about this more concentrated stock solution is that its concentration is 3 molar. So we're going to go ahead and fill that into our equation. And before I do anything else, I want to remind you that the number of what we're after, the real answer that we're after, is how much of this solution that I need to measure out. How many drops, how many milliliters of the strong stuff do I need to add water to make my new dilute solution? So I do not at all want to fill in this number here, this 3 liters of solution. It's a distracting piece of information. It's lovely that you have 3 liters of it, but you're never going to use all of it. We're really after a smaller number for the amount that we're actually going to use. So what I'd like you to do is just completely almost forget that that number exists. It'll be very helpful. Now, one thing that will also be helpful is to rearrange our equation a little bit. It's nice that we have moles divided by liters equals molarity, but I want to actually multiply the liters of solution over and kind of simplify the equation a little bit. Take a look at what I mean here. The molarity times the liters equals the moles. All of the numbers can still fill in the same way. It's just rearranging this algebraically. We can do the exact same thing for the solution that you're using, the stock concentrate solution. Let's rearrange him a little bit too. Again, the molarity equals, the molarity times the liters equals that moles. And remember that that's the one thing that they had in common. The moles from the dilute solution were the same as the moles from that concentrate solution, because that's where they're coming from. And what that enables me to do algebraically is make one big long equation. Since those two terms are the same, cancel them out. Let's keep simplifying our equation. What that means now is that the molarity and the liters multiplied together for the solution you're making equals the molarity times the liters of the solution that you're using. Let's simplify that even further. Instead of saying liters of solution, let's just put down volume. M times V equals M times V. A little hard to keep track of which M and which V belong to which solution, so what we're going to do is add in some subscripts, just for convenience. And that kind of looks like this. M1V1 equals M2V2. The molarity in the volume of the solution you're making equals the molarity in the volume of the solution that you're using. Since we have a really nice equation now, I think it might be time that we start to fill it in. So let's simplify this out a little bit. Let's fill in the molarity and the volume of the solution I'm making. That would be the 2 molar and 1 liter. Let's also fill in the information from the solution that I'm using. Remember that 3 liters was a nice number to have, but not entirely useful for this problem. But that 3 molar was. We need to know that. I'm still after the volume of the solution, the stock concentrated solution that I'm after. So again, ignore that 3 liters. Don't fill that in or else the math won't make any sense. And solve. We find out that we should be owing ourselves 0.66 liters of our very strong stock solution. Just like before when we were making the solution from a solid, this is a nice number to have, but this problem very clearly asks me to go forward and to explain how to make this solution. So I'm going to do this twice. Once kind of very specifically and once a little more generically. So here we go. So we have just a beaker full of strong blue solution. 3 liters, 3 molar. Now one thing to keep in mind again is that the molarity means, 3 molar means, we have 3 moles of solute per 1 liter of solution. If I have 3 liters of solution, that means I have 9 moles of material inside of my container. And I tried to represent that by using these cute little red triangles. Now what we need to make sure that we're doing is to measure out 0.66 liters of that solution. So I'm going to go grab a pipette and I'm going to remove exactly 0.66 liters or 660 milliliters. Now notice what that essentially equated to was 2 moles of material being removed from my container. Up next, the solution I'm making, I know I want to have a volume of 1 liter, so I'm going to go get a 1 liter volumetric flask. I'm going to transfer that blue material into the volumetric flask, and then finally I'm going to fill up the remainder of the space, diluting it all the way up to that line to give me a final volume of 1 liter, a final molarity 2 molar. You can see I have 2 moles per that 1 liter. So one more time, just to try and make sure that this makes sense, the steps for mixing a solution from a more concentrated solution. First of all, you have to measure out a specific volume of that stock concentrated solution. Remember the equation for calculating that is M1V1 equals M2V2. And the volume of the stock solution given in the problem never matters. You can ignore it. Step 2. Pour that volume into a volumetric flask. Make sure that the volume of your volumetric flask is the final volume that you're after for your solution. They make volumetric flasks in every kind of size, so you're not going to be limited at all by the volume of solution that you're supposed to be making. Step 3. Pour in some water. Don't ever fill the flask up all the way on the first go, because you want to make sure that you have room enough to mix until that solution is very well dissolved. After that takes place, of course, you can fill all the way up to the line very, very carefully, drop by drop, until the bottom of the meniscus kisses the line. Never want to fill past the line. If you add too much water, some of the solution actually mixes in with that extra water and you can't be guaranteed to have the perfect molarity solution anymore. And it's not a simple fix. You can't just take the solution back out, because then you're removing the solute, the stuff that's dissolved back in there. Unfortunately, usually what this means is you have to remix your solution. So pay a little bit of attention, make sure that you take a little bit of care when you're mixing your solutions, and I'm sure you will have success.